You know, I grew up in country like this. My dad and I would ride our horses up to these amazing high mountain lakes. We'd ride back into some pretty remote wilderness areas with incredible streams and meadows and wildlife. I love it here. Look at this canyon. It reminds me of the Grand Canyon. You got this little stream, you got these steep canyon walls. How long do you suppose it would take for a stream this small to remove this much material and cut the canyon this deep? This rock has a history, just like I do and just like you do. It came from somewhere. A lot of these rocks have been dated to be 350,000 years old, up to 2 million. That's pretty old. But it might surprise you to know that all of the geological formations that we see here, the canyons, the layers, even the plants, are younger than I am. When I was born, there was nothing here but a vast forest, hundreds of feet below where we're standing right now. In fact, before 1980, most people had never even heard of Mount St. Helens. It was in that year, on May the 18th, that molten rock created a steam blast with a force of 20 million tons of TNT. Avalanche debris and other flows from the eruption laid down all of those layers rapidly, up to 600 feet thick. A couple years later, there was some more volcanic activity that created a mud flow that cut out this entire canyon. It also cut through deep bedrock, all in a couple days. Isn't it amazing what a little bit of information from the past can do to help change your view of the present and the present world around you? There are a lot of assumptions made by a lot of people about the history of the earth around us. The question is, how do those assumptions affect how we view that history? But more importantly, how do they play into how we view science and the Bible? Did God create the world in a few days or billions of years? Is mankind descended from apes, or did God create us instantly in his image? Was there a global flood that destroyed the earth, or is that a myth? In other words, is Genesis history?
When we think about the history of the Earth, there are a lot of things we need to consider. But one of the most fascinating is the account of the flood. Was the whole earth covered with water? Genesis says the waters prevailed so mightily on the earth that all the high mountains under the whole heaven were covered. So if the flood was truly global, wouldn't there be a lot of evidence? I'd heard of a scientist who had spent over 40 years studying this question. When I spoke to him, he said he had a great place where we could see evidence for the global flood.
Steve, I gotta admit, I've been here several times, but every time I come here, it is breathtaking.
Besides being at home, Grand Canyon is my favorite place on earth.
Yeah. So, Steve, tell me, what do you see here?
When we look at Grand Canyon, we see the inside story to the ground beneath our feet. And we kind of have a layer cake here, don't we, of strata that have been eroded for our benefit to see the inside structure of the earth. These same layers are also in Colorado. We're also in Illinois, also in Pennsylvania.
So when you say sedimentary strata, you're talking about the layers that we see?
Yes. So the lowest layers are formed first. Those are sediment grains that were mixed, separated, and flowed in here from different directions and accumulated one on top of another. And then, of course, naturally, they convert to rock.
So you're saying that the solid ground we're standing on right now, if we went back in its history, it'd be liquid?
Yes. So the ocean is doing some amazing things, and water of incredible power is depositing the layers we see in the canyon.
And are there fossils in all of those layers?
There are marine fossils through all the layers. But the standard explanation is there were 17 different advances and retreats of the ocean over the North American continent, and it was extended over hundreds of millions of years.
And what is the evidence that you see here that would say that doesn't seem to make sense?
The 4,000 feet of flat-lying strata in the canyon are flat, and relative to one another, we look in between the strata layers and we don't see the passage of time in between layers.
You mean erosion?
Erosion, especially, and channeling on any great scale is not visible. And then we look at the strata themselves, and they provide evidence of rapid, very rapid sedimentation. Just minutes or hours is all that's needed to make layers.
Well, tell me about the story of these layers. I mean, how did they get here?
In the 600th year of Noah's life, on the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up and the windows of heaven were opened. My understanding is the ocean floor upheaval occurred. Some type of magma or earthquake propelled the oceans over the continent.
So that's why we get these marine fossils in these layers.
Yes, and we have 6 months the waters prevailed upon the earth, another 7 months or so for the water to subside. The 4,000 feet of strata probably represents the early and middle part of the global flood right here in Grand Canyon. We have other strata locally in this Grand Canyon region. That's called the Grand Staircase. We have about 10,000 feet, 2 miles thickness of strata on top of the Grand Canyon.
Higher than where we are.
Higher than where we are. And that represents the later stages of the flood and the retreat of the floodwater. This surface was beveled by retreat of floodwaters. And as the flood retreated into the newly formed ocean basins, then the continents probably uplifted, and the ark, of course, was landed in the high country in the Middle East.
Well, there's some people who say that that record is about a local flood.
I believe it's a global flood, and all the high hills, or the whole heaven, were covered, a universal statement. But that mountains have risen since then, and we shouldn't measure the depth of the floodwaters by the present mountains of the earth, which are largely created during the flood and after the flood.
Well, the fact that we have all of these layers would be unknown to us if we were standing on them, somewhere else, but they're known to us because they've been cut out. How did that happen?
Well, it was the story that we all learned in grammar school. Okay, Colorado River, over tens of millions of years, cut the Grand Canyon. Most geologists have jettisoned that idea. It's hard to sustain a canyon like this for tens of millions of years. You can't imagine a canyon enduring that long with erosion.
Is that because it would have eventually, the sides would have collapsed and broken down? Then how in the world do we get this all carved out?
Well, there are lots of theories, and personally, I like the idea of catastrophic erosion by drainage of lakes.
So after the flood, we have these large bodies of water, these lakes that are trapped.
There's evidence of the big lake in the Painted Desert, a place called Hopi Buttes, about 500 cubic miles of water in this huge lake.
And so the dam breaks, and all of that massive amount of water then is now pouring out and carving this.
Yes, and how long would it take to erode Grand Canyon? Maybe weeks, but not millions of years. Time is not a magic wand that solves all the geologic problems of the world. Jettison that way of thinking about millions of years and then start thinking about catastrophic process like you've seen at Mount St. Helens, and that'll help you understand Grand Canyon.
Everywhere we looked, Steve showed me evidence of the incredible power of moving water. It quickly laid down these enormous layers, then quickly eroded them away. Steve wanted to show me where the floodwaters first hit the continent, so he took me deeper into the canyon.
Steve, when you said you were going to bring me to the bottom, you weren't kidding, were you? We're at the bottom, aren't we?
So we're in this big side canyon to the main Grand Canyon, and we're looking at the granite basement rock, which is the core of the continent, if you will. And then we see the flat-lying strata on top of it. The boundary between the granite rock below and the Tapete sandstone above is this surface we call the Great Unconformity.
Why does it appear to be such a stark line? I mean, it's clear.
I think it's an erosional boundary of colossal scale. We're looking at something that shows the magnitude of flood flow over a surface.
And is it just here?
The Great Unconformity is continent-wide. I've seen it, I believe, in the Middle East. It's over in Europe. It's in Africa, and here it is under the North American continent.
So we've got this layer. How thick is this layer? What goes up from here?
Well, we have the Sauk mega sequence here, if you will, 1,000 feet of sandstone, shale, limestone that goes continent-wide. There are 4 other big sequence packages of strata that sit above it. Those are also very continuous like this. What we're seeing here is rather representative of the rest of the world.
It makes one really question the notion that this all happened because of a small local flood. We're talking about something enormous.
The power-moving water was beveling and pulverizing rock, depositing great thicknesses of layers and calling our minds to think about a global flood.
The conventional story is entirely different, though. It would say that there is a lot of time between each of these layers.
Some people have said that the Great Unconformity boundary here represents 500 million years.
You mean between the granite we see and that first layer of the sedimentary rock?
Yeah, they say that there may be 500 million years there. Okay, and that's what their explanation of Earth history would ask them to consider. Yet when you come here and look at this, nearly a featureless plain. It's not exactly a plain, but it's a gently rolling surface. And would that be the product of billions of years? Or would that be the product of the power of water planing off a surface? Time is foreign to a good explanation here. And so we want to explain what we see. Everywhere we look, we see the power of water. And it's water on a colossal scale, and that's the story here in Grand Canyon. It's not a little water and a lot of time. It's a lot of water and a little time.
Time really is the central issue when talking about the history of the Earth. How much time did it take to form what we see around us? It seemed clear to me that a global flood would have transformed the Earth quickly. Yet I know many people think that the world formed slowly over billions of years. What was the real difference between these two views of time? I needed to talk to someone who could tell me more about science and history and time. Since my background is in computer science, we met at a place where I had personally experienced some of that history. As we looked at the exhibit, I was reminded how much smaller and more powerful computers have become since I first started using them. Paul said our changing assumptions about computers were really a series of paradigm shifts.
So when I was 19, I read Thomas Kuhn's classic, The Structure of Scientific Revolutions, where he describes this notion of paradigms. A paradigm is a framework within which you interpret evidence. So really, science isn't just about the evidence, it's about how you interpret that evidence. So this room, for example, we've got so-called mini computers here, but really they're not mini at all in terms of our current paradigm.
Yeah, today, right?
Yeah, this.
Yeah.
Right? So really, to understand this question of origins, you really need to begin by looking at the governing paradigms, the two major views that we currently have about the history of life and the history of the universe.
And what are those?
On the one hand, we have the conventional paradigm. In the conventional paradigm, you've got deep time. 13.7 billion years, along which this gradual process, beginning with primal simplicity, ending in what we see today. All the complexity in life has to be built bottom up by strictly physical processes where no mind, no creator, no design is present. The second view we can call, let's say, the historical Genesis paradigm. Everything starts with a divine mind, a creator, an intelligence that plans and superintends and brings into existence reality. Events are happening on a much more recent time scale. The universe, the solar system, our planet, life itself, all of that begins fully formed as a functioning system.
It's not hard to see there's a radical difference between those two in terms of time.
When we look at the history of life on this planet, we've got a body of data, but depending on the paradigm that one adopts, that data will be interpreted in very different ways.
It seems that one paradigm is drawing on a history that was given to us.
Yes.
And another paradigm is constructing that history. Is that how you see that?
We have a witness to those events. And that witness is telling us this is what happened, and we have to take that into consideration when we evaluate the data.
Well, Paul, the reason this becomes serious is that we're not talking about a history of just boiling water at a certain temperature. You know,
Right.
We're talking about a history that deals with the origin of the universe. It deals with the origin of life, the origin of humanity, the origin of sin and why there's evil in the world, the origin of the geological formations that we have around us, the origin of language. I mean, this is history that is not minor. This is dealing with major, major elements of humanity and where we are.
You're talking about the origin of literally everything. And I think if we zoom out from that and say, well, what really is the difference between these two paradigms? It isn't a question of science on the one hand versus religion on the other, because both of them are scientific in the sense of looking at a common body of data. Really, at the deepest level, the difference is two competing views of history. What is the true history of our cosmos?
That does seem to be the real question. What is our true history? What actually happened? The conflict is not between two views of science, but between two competing views of history. Since Genesis was written in Hebrew, I wanted to talk to a Hebrew expert. What was actually in the original text?
The first word in Genesis is Breshit. Genesis 1:1 is Breshit bara Elohim et hashamayim ve'et ha'aretz. So this is the beginning of the Toledot of Noah. Interesting that that word Toledot is a very interesting word. It's translated sometimes genealogy, sometimes it's translated history. And what follows then is the account of the flood.
Steve, it seems that there is a lot of history in the Bible. Is that how you see it?
Oh, absolutely. In fact, the first thing is that it's an accurate historical account. The presentation is such, and the perspective of the writers, that they believed they were talking about real events.
Okay.
It's very obvious that because of the way in which they insist that the next generation learn their history.
When you look at these early chapters in Genesis, what do you see? Can you take us through this?
It starts with, in the beginning, God created the heaven and the earth. There's no word in Hebrew for universe. That means he created everything. And then the next thing we find in Genesis 1:2, we find a water ball that is in space. God, in the subsequent days, is going to fill that universe.
Well, you're talking about days here. Do you see these as literal days? Is that what the text is telling us? Or you know what other people think, that this is just a poetic, different
Well, first of all, it's not poetry. The world's greatest Hebraists all affirm that this is a narrative. They say that that's one of the unique features of the Genesis accounts of creation and the flood, is that they are narratives, because in the ancient Near East, they are done in epic poetry, which is very different. And here we have narrative to indicate that this is historical. What that means is that you should understand the words the normal way in which those Hebrew words are understood. The word yom, it means day. The foundation of its usage is what we mean by a day. It's a 24-hour day. The only way you'd want it to mean a longer period of time is if you impose an alien concept to the text and say, well, I think that these are ages, and therefore yom has to mean ages. What you have to do is start with the text. Yeah. If we start with the text, yom means day.
So when we come to the passage that talks about the creation of Adam and Eve, you're seeing that as a clear historical event which would stand in direct opposition to the conventional paradigm that man evolved out of a long, long process.
The biblical text is not compatible with the standard, the conventional paradigm. The Bible teaches that the Lord God formed man, artistically breathed in him the breath of life, created him in his image. And then, of course, woman is created. We have marriage. We have the fall. And then in Noah's genealogy, we have the entire flood account. And the flood, is it a global flood? Well, I mean, I don't know how many times, I think 35 times or so, the word kol, which is all, occurs in the flood narrative. If this is a judgment on mankind, then it has to be global. We continue through these first 11 chapters of Genesis. We come to chapter 10, which is called the Table of the Nations, which are the sons of Noah. It mentions in that chapter that the people are in their different nations and their languages. So Moses goes back in Genesis 11, 1 through 9, and explains how the languages develop. And so we come to the Toledot of Terah. And the Toledot of Terah is not going to be about Terah. It's going to be about his famous son, Abraham.
It just seems so apparent that there is no disconnect between all of that and everything that we see in the beginning. It's just one long historical narrative, is it not?
It is. As a matter of fact, the genealogies form the structure, not just for Genesis, but the narratives are embedded in the genealogies. The genealogies are picked up, that's actually called the Toledot, in the book of Ruth, to establish that David is a descendant of Judah, which is required by Jacob's prophecy. And then we move into the New Testament. How is the pedigree of Jesus established? With two genealogy, one going back through Mary's line, all the way back to Adam.
Steve, in light of all of this that we have seen, how important is the historical narrative that we find throughout Genesis, including all of the generations that are laid out there? How important is that to Christianity?
It shows that Christianity has a historical basis. It's what the scriptures say, and the scriptures represent actual historical data. So Christianity it's not a leap in the dark. It is understanding that it has a very strong historical basis, and that our Savior is also our Creator.
These genealogies are incredibly important. If Jesus is descended from Adam, and Adam was created on the sixth day of creation, then the earth can't be very old. So where do the millions of years come from? I met a geologist at a place where he said we could understand this better.
You see the quietness, the expanse, nothing to disturb you. Yet you've got the reminder that it was explosive in the past. There was this volcano back here, the Cone volcano, and it belched out this lava flow that spilled out across this countryside.
Just a huge amount of basalt, lava.
Yeah, but it's actually small compared to the lava flows that we see in many places. And there's something like 1,000 of these volcanoes around here. And the little one behind us here, we call that a cinder cone volcano.
You call that a little one?
Yeah, well, it is. I mean, these volcanoes are small. Mount St. Helens, 1980, when it erupted, okay? The top 2,500 feet of the volcano blew off, but that was small compared to historical eruptions. We can go back a little bit further to the Great Yellowstone eruption, and some of the volcanic ash was down in Texas. It blew that far away. You think about lava flows in India, that you have an accumulation of up to 1,000 feet over an area a third of the size of the subcontinent of India. what we see in the present is really only minuscule by comparison to what we've seen in the past. And that's telling us something about the historic past. We can't use present-day rates of these processes to understand how quickly and how majestically, in terms of scale, the geological record accumulated.
Well, that is the point that has brought me to you, because how do we determine the age of these rocks?
Well, the important first thing is to recognise that this lava flow is, in a sense, an instant in time. It's an event. And when it's molten, you've got all the different elements that have come out of the volcano are all mixed up, and the rock starts to crystallise. Any of those atoms that are radioactive, they now start to accumulate what we call the daughter products, the decay products. Now, the point is that this rate of decay is so slow when we measure it in the present that, it takes millions of years for parent atoms to decay to daughter atoms. And so that's ultimately where the millions of years come from, the fact that the decay rates in the present are slow.
But we would say that the present is not really the key to the past, because obviously the past holds some massive, massive catastrophic events that are not going on today.
In fact, the Bible would say that the past is the key to the present. If you want to understand why the way the world is today, you've got to understand what happened in the past. So we've got lots of hints that geological processes haven't been at constant rates through time, and we have other hints that the decay rates may not have been constant. See, we've taken rock samples from a number of places, lots of samples in the Grand Canyon of each of these rock layers. I've done it in New Zealand, we've done it in other parts of the world, and what we've done is we've submitted the same samples to more than one of these dating methods. And so what we found is on the same samples with more than one method, we were getting ages that were different by hundreds of millions of years, or even a billion years in some instances. We're seeing huge differences by using different methods.
Well, if there is that kind of a difference between all of these dating methods, then that would seem to confirm the fact that we have an open system here, not a closed one.
And if we have an open system, that means we can't trust it to give us dependable dates for these rocks. And that changes the whole thinking about the history of the Earth, because suddenly now these radioactive clocks are not reliable. We've got evidence that rates were faster in the past. Suddenly, we may not be thinking in terms of millions of years. We may be thinking in terms of a history that is much shorter.
But you were saying that this kind of evidence is in the open literature now.
Yes.
Why is it not making an impact?
Well, I've been asked that when I've spoken in university geology departments, and the answer is because there is a commitment to the millions of years. And so once people get locked into that focus, anything outside their field of view that conflicts with that focus is marginalised. And the reason why the millions of years are important, if we go back in the history of scientific thought, Charles Lyell in England proposed millions of years, and they multiplied the ages for the rocks. And that was the foundation on which Charles Darwin built. In fact, he read Charles Lyell's book and was convinced of the millions of years of geological evolution, so he could say, now, given enough time, what we don't see happening in the present, we might only see small changes in the present. Given millions of years, the small changes can add up to big changes. And so if you want to have a way of looking at the history that says that we got here by chance, random processes over millions of years, then you've got to have rocks that are millions of years old. Otherwise, you've undermined that whole foundation of that view of Earth history.
So time becomes the critical element for the conventional paradigm.
Exactly.
And that time has to be deep time.
Andrew said when you study the rock formations, they show evidence of a young Earth transformed by a global catastrophe. So he took me south to Sedona to see it for myself.
The important thing to note is that this landscape is actually very stable. There was lots of erosion in the past to carve out this whole terrain, but those cliffs and the valley floor are very stable, which is why you've got the vegetation. Today, everything's much, much quieter. Today's processes are extremely slow, but they can't explain how we got this erosion, how we got these layers, how we got these cliffs.
All right, so you wanted to come here because you see evidence of a young Earth because of what's here. What do you see?
Yes, well, the first thing we notice is the extent of these layers. It's like a stack of pancakes. For example, the red unit that goes all the way across our field of view, that's the Schnebly Hill Formation. And above that, you can see the first white unit is the Coconino Sandstone. And above that, you've got the Turaweep, and at the horizon, you've got the Kaibab Limestone, which is the rim rock of the Grand Canyon. And, you know, here we are, 70 more miles from the Grand Canyon, and these layers are still here.
Yeah. It's almost hard to imagine the volume of material that represents.
Yes, take the Coconino Sandstone. We can trace it from here, right across New Mexico, Colorado, right over towards Kansas and Oklahoma, and even in Texas. We're talking at least 200,000 square miles for this one rock unit that's consistent for mile after mile after mile. That's not the scale that we see today with localised sedimentation. And to get it flat lying like this over such a large area, it's like you have to make your pancake all at once very rapidly. And so these layers show evidence of rapid sedimentation, the extent of these layers.
Well, Andrew, you were talking about that red formation, but that doesn't sound familiar to me.
No, that's the Schnebly Hill Formation. It's not in the Grand Canyon. In the Grand Canyon, we go from the Coconino into the Hermit Formation. There's that knife edge boundary, and there's no evidence of erosion there, which means that the Hermit Formation was rapidly deposited, and then immediately the Coconino was a deposit on top of it. But here, we've come 70 miles from the Grand Canyon, and we've got this Schnebly Hill Formation between the Coconino and the Hermit. And this Schnebly Hill Formation, 800 to 1,000 feet thick, over an area of 1,000 square miles, had to have been formed very rapidly. If that took millions of years, we ought to see millions of years, evidence of millions of years erosion back in the Grand Canyon at that same boundary. We don't. So that means that this Schnebly Hill Formation in this area had to form in a matter of hours. So it tells you that not only is there a lack of erosion, but there's no time between those boundaries. So the whole sequence of layers was very rapidly deposited.
So we have this large extent of layers. We have the lack of erosion between the layers. What other evidence do you see?
Well, if we look closely, for example, at the Coconino Sandstone, we see the bedding, that there's bands within it that are sloping. We call those cross beds. What they indicate is that you had underwater sand waves were moving along. The comparison is in a desert. It's important to recognise that there's a difference in the angle in a desert dune. It's usually 30 to 34 degrees of these sloping beds. Underwater, it's usually 25 degrees or less. And Dr. John Whitmore has combed the hills around here with his students, hundreds and hundreds of measurements of these cross beds. And they all come in the range of 15 to 25 degrees. So it was underwater deposition. And so these layers are accumulating in hours, weeks, and within months, you've got this whole stack of pancake layers over such wide areas.
So it isn't a difference in believing in those layers that exist.
Not at all.
It's the difference of time, isn't it?
Correct. It's not a question of science versus the Bible. When we're talking about the flood paradigm and the conventional paradigm, we're actually talking about two different views of Earth history.
Those views really are different. Of course, I grew up being taught the conventional view with its long ages and slow, uniform changes. But what was the history of the world according to Genesis?